Alright, so we're going to try this out here. The problem, we're going to be using Chinese Remainder Theorem. Problem is we have to find a polynomial of minimal degree so that it satisfies these three congruences. Alright. So like I said, we're going to use Chinese Remainder Theorem. We're going to, basically what we're trying to find is, we're trying to find this polynomial, f of x. Let's see. Okay. Such that we're going to be finding these three things. We're going to find h1, h2, and h3 that correspond to each one of these congruences. Okay, so we're going to have h1 times the congruence of the first, plus h2 times the congruence of the second, so times 1, that's just going to be h2. And then plus h3 times x plus 1. Right. Alright, so our goal is we gotta find this h1, this h2, and this h3. Alright, first up, find h1. Okay. Now when we find h1, we're gonna split it up into two different functions. We're gonna have I'm just gonna label it, it's m1 of x, I'm just gonna label it m1, and l1 of x, I'll just label l1. Okay. So starting with h1, I'm gonna leave a little space because again what we're trying to find here is h1, h2, h3. Okay. Alright, so starting with h1. That's better. Alright, h1, we're going to start with m1. Okay. Now m1 is just going to be the mod part, which was x squared plus 2. Okay. And then this L1 part. Now usually what you do is for L1 you multiply all the mods together and then divide by whichever one you're starting with. Okay. So basically what that means is we're just going to multiply the second mod, which is x, and the third mod, which is x squared plus 2x plus 2. And we'll just multiply those together. Okay. So L1 is x times x squared plus 2x plus 2. Okay. Alright, now the whole issue is we're going to be dealing with this L1. We need to kind of rearrange it a little bit. So we're going to simplify this first. Gives us x squared, or no, excuse me, x cubed plus 2x squared plus 2x. Okay. And we want to be able to rewrite this in terms of m1 and l1, because again, whatever's in, the l1 is what we're looking for really. So we have to figure out a way to write this in terms of x squared plus 2. Okay. Now for some of these you could use it like introspectively, you could just look at it, right? But this one's not too intuitive, so I'm just going to divide them. Okay, so I'm going to take the x squared plus 2, which is our m1. And I'm just going to divide it by this x cubed. That should be x squared, 2x squared. X cubed plus 2x squared plus 2x. And we'll just divide. Alright, so long division, we got to find what times x squared is going to give us x cubed, and that's x. Okay, multiply it out, x cubed plus 2x over here. Subtract, that goes away, this goes away, this gives us 2x squared. Okay, now we repeat the process. What times x squared is going to give us 2x squared? Okay, well obviously we're just going to multiply by 2. Okay, multiply that out, 2x squared plus 4. Okay, now there's no linear term up here, so it's just 0. Okay. So when you subtract these, you end up, this goes away, and you end up with a remainder of -4. Now the problem is we're in mod 3. The whole problem's in f mod 3. So this means we could only have integers of 0, 1, and 2. Okay. Which means all we have to do is, if we're trying to change -4 to, the number mod 3, you just add 3 and you get -1. You add 3 again and you get +2. Okay. So -4 in, f mod 3 is just +2. Alright. So our remainder is +2, which means we could rewrite L1. Okay. We're going to rewrite it as L1 is equal to our quotient here times the divisor plus the remainder. Okay. So it'll be x plus 2 times x squared plus 2, which is really just m1. Okay, so we'll say times m1 plus the remainder plus 2. Okay. Alright, so using what we want to do is we want to solve for the constant term here. So if this is true, then if we solve for 2, we're just going to end up with 2 equals, it'll be L1 minus x plus 2 times m1. And ultimately, we're trying to get Bézout's theorem here. So Bézout's theorem, we need to have 1 as the constant term. Okay. So since we're in mod 3, we can't really divide by 1/2. Okay. So usually you divide by 2. What we're going to do instead is we're going to multiply by 2, because if we want this to become 1. Okay. We want 2 to become 1. If we multiply 2 by 2, it'll become 4. Okay. Well, 4 mod 3 is 1. Which is what we want. Okay, so we're going to multiply everything by 2. This gives us 1 here. It'll be 2 times L1 minus 2 x plus 2 times m1. Okay, now none of this stuff really, this whole thing doesn't matter. The whole m1, anything in front of m1 doesn't matter. What we're looking for here is we're looking for whatever's with the L1. Okay, so whatever this is going to be our H1. Alright, so our H1 is 2 times L1. Okay, well, if you remember up from the beginning, L1 was x cubed plus 2x squared plus 2x. Okay, which means H1 is just going to be 2 times all that. Okay. So H1 is 2 times x cubed plus 2x squared plus 2x. Okay. Now when we distribute, again, we have to remember we're in mod 3. So anything greater than 3, or really greater than 2, we're going to have to change to whatever the remainder would be. Okay. So if we distribute this, H1 is going to be 2x cubed plus, this would be 4x squared, but in mod 3 it's just 1x squared. Okay. And same thing with the x value. 2 times 2 would be 4x, but again we're in mod 3, so it'll be 1x. Alright, so that's our H1. H1 is going to be 2x cubed plus x squared plus x. Okay. So I'm going to plug that in up here. Okay, 2x cubed plus x squared plus 1. Or no, plus x. 1x. Alright, so we found H1. Now we gotta find H2 and H3, and it's the same process. For H1 we used the first mod and then multiplied these other ones for L1. For H2, M2 is gonna be x. And then L2 is going to be x squared plus 2 times x squared plus 2x plus 2. Okay. So you just remove the one you're using and multiply the other two together. Alright, so let's do that. Got H1, that's done. Okay. On to H2. Okay. Well, M2 is the mod for the second congruence, which is just x. And L2 is going to be the other mods multiplied together. So x squared plus 2. And then x squared plus 2x plus 2. Okay. So we'll distribute, multiply these out. We'll end up with x to the 4th plus 2x cubed plus x squared plus x plus 1. Okay. So remember, we're in mod 3, so the constant was 2 times 2, which is 4. Mod 3 is 1. Alright, we're going to do the same thing. We need to try and write this in terms of m2, which is x. Now this one I'm going to do kind of intuitively. Instead of doing long division, which is fine, you could do long division and do it the same way we did for h1. Instead, I realized m2 is only x. Okay. Well, 4 of these terms have x in it. What we could do is we could just factor out an x. Leaves behind x to the 3rd plus 2x squared plus x plus 1. Okay. And then you still have the constant out here, which we didn't take an x out of, obviously, because it doesn't have an x. Alright. So now what we have, really, is L2 equals times this whole thing. Plus 1 at the end. Alright, so again, we're trying to find, Bayes' theorem said, 1 equals all this other stuff. So we gotta get the 1 by itself. If we solve for the 1, we get 1 equal to L2 minus M2 times that whole thing, x cubed plus 2x squared plus x plus 1. Again, we don't really care what's with the M2. All we care about is what's with the L2. Okay. Well, the L2, there's nothing in front of it. It's just x. It's just L2. Okay. So that means this is our H2. All right. All right. So that means H2 is just that whole. What we started with, this original thing, the x to the 4th plus 2x cubed plus x squared plus x plus 1. That's what H2 equals. Okay. Alright, I'm going to write it up top in the space we left. Alright, so we got x to the 4th plus 2x to the 3rd. Plus x squared plus x plus 1. Okay. Now last one's h3, which is probably the hardest of all of them because you end up with a non-constant remainder. So we actually have to do it in another step. Alright, so let's see that. h3. Alright, so we got to find M3 first. M3 is the mod, so it's the quadratic mod, x squared plus x squared plus 2x plus 2. Alright. And then L1 is the other mods multiplied together, which is x times x squared plus 2. Okay. Multiply that out, you get x cubed plus 2x.